Welcome to Engineering Studio with Dr. Mohammed Tahir. From this video, we are going to start a new chapter related to design of steel beams. In this chapter, we will learn the design of beams using doubly symmetric, compact eye-shaped members and channels bent about their major axis. So we will only deal with the compact sections, WR, channel section, and these should be bent about their major axis. For the following cases, so we will consider these three cases. The first one is continuously braced compression flanges. If the compression flange of this member is continuously braced, and the second option is lateral bracing at intermediate and end points. So we have lateral bracing at this point and at some intermediate points against the lateral torsional buckling. And the third case is when the beam with lateral bracing at ends only. So if we have the bracing, lateral bracing at the ends only. So we will consider these three cases. If we talk about the content of this chapter, so we have a large number of contents that will be covered in this chapter. So in this video, we are going to cover these beams and their types. The remaining, the type of section, lateral supports, bending stresses and bending behavior of compact member, failure modes, nominal strength, design shear, deflection, procedure for the design of beam, and the solved examples that will be covered in the next videos. So in this video, we will cover this first topic. So first of all, beam. A beam is a structural member in which the major deflection is bending. So here, the major deformation is bending. So the bending moment is primarily generated due to transverse load. So transverse load act on the beam, transverse to their longitudinal axis. This member carries the load throughout its span and transfer it to the ends with or without accompanying any movement. So if we apply the load over here, so this load will be transmitted or transferred at their ends to the next member, which is columns or walls. And there can be only reaction, mean vertical reaction, or there can be any bending moment as well as based on the end conditions. Beam is a combination of compression members on one side of the neutral axis and tension member on the other side. So if we see a beam, so it will have a compression member on one side of the neutral axis and tension member on the other side of the neutral axis. So this lightly shaded area shows the neutral axis or the area where there is no stress, and the top will be under compression and the bottom will be under tension when the beam is subjected to the transverse load. And these compression member and tension member are joined together through a shear element. So if we see over here, so this flange is, the top flange is compression and the bottom flange is a tension member, and in between we have this web, so which is a shear element. So we connect these flanges with the help of this shear element, which is termed as web. So next are the types of beams. So we have actually three types of beam. If I write primary beam, secondary, and then joist or stringers. So we have mainly these three types of beam. So the primary beams, which are also termed as girders. So in case of steel, we term it as girder. So the primary beams that are frequently used at wide spacing, supporting the smaller beams and other structural components are called girders. So these run between the columns, column to column. Their span is between column to column, and they support the secondary beams or some other structural elements. Frequently, girders are made up of build-up sections. So mostly in case of steel, these girders are made up of built-up section because they have larger span and they are supporting larger loads. So the hard rolled section are insufficient for that span as well as loading. So we need to go for the built-up section. So these are supported directly on the column. So the primary beams or girders are directly supported on the column. So from this column up to this column, the beam will be termed as girder or primary beam. Then secondary beams, these are relatively smaller beams resting on the primary beams or girders, carrying load of lesser part of the root and having smaller span. So if this is our primary beam between the columns, on this side again this is the primary beam, so the beams which are running perpendicular to this will be secondary beams. Okay, next is joists. Joists are closely spaced and frequently having truss type webs. So this is primary beam, these are secondary beams, and beams which are perpendicular to the secondary beams will be joist. So these are joists. So these joists are normally very closely spaced. So they support the very smaller area of the roof and they have very less span. So their span will be from this secondary beam up to the next secondary beam. So here if we see, so this is the primary beam or girder. The beam which is perpendicular to that girder is secondary beam, or in case of bridges we term it as a floor beam, and the beam which is perpendicular to the secondary beam, this is termed as joist. So these are very closely spaced. So the purpose of providing these joists is to minimize the strength requirement of the slab. So with the presence of joists, the strength requirement of the roof sheeting or slab are greatly reduced. So when we provide the joist at closer spacing, the strength requirement, or we can say the thickness requirement of the slab is significantly reduced because of the lesser span. Here the span of the slab will be only this one. Okay, next is stringer. So these stringer are, we can say, comparable to the joist. So in case of bridges, we term them as a stringers. So longitudinal bridge beams spanning between the floor beams, or we can say secondary beams, are placed parallel to the roadway are called stringer. So if in case of bridge structure, so this primary beam will be termed as girder, this secondary beam will be termed as floor beam, and this joist will be termed as stringer. So they will run along the center line of the road. So here we can see, here we have a deck slab. So these are stringers which are running parallel to the roadway, and these stringers are resting on the floor beam, and these floor beam are resting on the girders or trusses. And these girder or trusses are spanning between the embankments or between the columns. The next type is lintel beam. So lintels are members supporting a wall over the window or door opening. So in case of wall, so here we have a door opening. So above the door opening or window opening, we provide a smaller beam. So this smaller beam is termed as a lintel, and this supports the load of the wall above this opening. Next is spandrel. So spandrel are actually the edge beams. So in case of buildings, so for example we have column over here like this. So we have many beams. So in case of high-rise building, we have walls at the outer periphery, and the load of these walls is significantly high. So the slab alone cannot resist the weight of these walls, or the walls itself cannot resist their load because of the high-rise building. So the bottom story walls will be subjected to significantly high load. So in that case, we need to provide a beam at the edges that will support the load of the wall above it. So this beam is termed as spandrel beam. So next is purlin. So these are the beams in case of truss roof system. So these are spanning between the panel points or between the trusses. We normally use Z section or angle section or channel section for the purlins. So if we talk about the spans of primary, secondary and tertiary or joist beams, so the main beams are primary beams. In case of hot rolled section, their span should be less than 12 meters, and the span of secondary beams lie between 4 and 6 meters, and the span of steel joist lies between 2 to 4 meters. So if the span of beam is primary beam is more than 12 meters, so we need to go for the built-up section, or we need to go for the truss. So next is the type of beams based on their position. So based on the position, we can differentiate them as a central beam or interior beam and end beams or edge beams. Because in case of structure, the loading on the interior beam and edge beam are different. So in case of interior beam, so this much portion of slab will be supported by this beam, and the span on both sides of the beam will be almost similar. But if we talk about this edge beam, here the span on one side there will be sufficient span, and the load will be acting on only one side of the beam. There is no slab on the other side. So as a result, this beam will be subjected to torsional stresses. So if we draw its figure, so it will be like this. So this edge beam, because the load will be acting over here, the resultant of the load, so this beam will be subjected to the torsional moment. So that's why the design of this edge beam will be different from the interior beam. We need to consider the torsion in case of edge beam as well. That's why we can differentiate them as a central or interior beam and end beam or edge beam. Types of beam based on their end conditions. So we are familiar from the structural analysis. We have cantilever beam if once we have support on one side only and the support is fixed ended. So then it will be termed as a cantilever beam. If we have pin support or roller support on one side and roller support on the other side, then it will be termed as simply supported beam. And if we have overhangs on one or two sides of the supports, so then it will be termed as overhanging beam. And if we have more than two supports in the beam, then it will be termed as continuous beam. And if the both ends of the beam are fixed, so it will be termed as fixed ended beam. And if we have one end fixed and the other end roller, so it will be termed as cantilever simply supported, or we can term it as a propped cantilever beam. Okay, next type of beam is based on the fabrication. So we can make the beams, or we can fabricate the beams by using hot rolled sections. So we can use S section, W section, channel sections. So if we use the hot rolled section, so then it will be termed as a rolled section beam. Or we can use cold form section, just like this Z section for the purlin. So this can be used. Other different possibilities of section are also available, like sigma section, channel section. So we can make our required shape for the beam. We can also use the built-up sections to make the beam. So if the hot roll section alone is insufficient to resist the applied loads and the span is significantly high, more than the 12 meters, so then we need to go for the built-up section. So if beam is constructed by using built-up section, so we can say it is a built-up section beam. Okay, next, which is important, this is a composite section beam. So when steel beam and some part of the reinforced concrete slab act together due to some type of shear connection between the two, the resulting beam is said to have a composite action. So if we embed the compression flange of W section in the concrete, or if we connect the concrete slab and this flange by using these shear connectors, so in that case some part of this slab will act to resist the flexural stresses. So if some part of slab is also resisting the flexural stresses, then this beam will be termed as a composite beam. So there